Hey, in this tutorial we're looking at section 5.5 on differentiation of trigonometric functions. Okay, so we've got a few rules here that we can go through. So, if we have f of x equals sine of x, then f dash of x equals cos of x. If f of x equals sine of kx, where k is just a constant, if you like, k is an element of all real numbers, okay, then our derivative is k times cos of kx, so that constant just comes out the front. If we have f of x equals sine of g of x, so we've got a more complicated function inside our sine function, then f dash of x equals g dash of x cos of g of x. If we have f of x equals cos of x, then f dash of x equals minus sine of x. If we have f of x equals cos of kx, then f dash of x equals negative k sine of kx. So again, our constant just comes out the front. And again, similarly, if we have f of x equals cos of g of x, g is some other function, then f dash of x equals negative g dash of x sine of g of x. If we have f of x equals tan of x, then f dash of x equals 1 on cos squared of x. Okay, and those guys doing specialist as well would know that that's sec squared of x. Okay, if f of x equals tan of kx, then f dash of x will equal k on cos squared of kx, or k sec squared of kx. Okay, and if f of x equals tan of g of x, okay, where again g is a function, then f dash of x equals g dash of x on cos squared of g of x, which is the same as g dash of x times sec squared of g of x. So by definition, okay, sec of theta equals 1 over cos of theta. Okay, so when we have cos squared of x, okay, that means that it's sec squared. Okay, and remember, when we're saying sec squared of x, that really means that we've got sec of x times sec of x as well. Okay, it's just we put the squared there to be able to tell the difference between this and that, where we actually have our x value that's been squared. Okay, so we'll have a look at a couple of worked examples. Okay, so we have f of x equals sine of 8x plus x to the 4. We're going to differentiate that. So we can just say, well, f dash of x, okay, sine goes to cos, and we've got a constant for our x, so that's got to come out the front. So we'll get 8 we'll get 8 cos of 8x. Okay, and then we've got to differentiate our polynomial. Okay, remember our 4 comes down the front, so it'll be 4x cubed. That's all we've got for that one. For this one here, our tan and our cos part here. So our tan, we know straight away that that goes to sec squared, and our 5 comes out the front. And so we get 5 times sec squared of 5x. Okay, plus, okay, we've got a function here. So it's the derivative of this function. Derivative of x squared is 2x. Times 2 will give us our 4x. And, sorry, I mucked up there. It shouldn't be plus. It'll be minus because cos goes to minus sine. So it'll actually be minus 4 sine of x squared. Okay, for that one. Sorry about that little mistake. Okay, and with our last one here, we've got a little bit of work to do for that one by the looks of it, doesn't it? Because we've got that division part there. So what we want to do, okay, is we actually have an identity here that we can use. So for our f of x, okay, 1 minus sine squared is equal to cos squared of x over cos of x. Okay, which means that that's equal to cos of x. Okay, so our identity that we use, specialist students will have seen this before, is that sine squared of x plus cos squared of x equals 1. Okay, so we're just rearranging that, okay, to take our sine squared away to get that that's equal to cos squared. So we need to make sure that we are familiar with and can utilise that identity. Okay, so we've got our f of x equals cos of x, so then f dash of x just equals minus sine of x. Okay, so what's this one look like? It'd be quite a complicated formula. Okay, if we do a little bit of our work with trig and our identities, we can get down to be a lot simpler. This would be a pretty good example actually where method students may look at this and go, well, I'm going to have to use the quotient rule, which is a little bit later on, but quotient rule because I've got one function divided by another function, okay, and do it a long way to end up getting to this, where specialist students have had to use our identities a lot more. We'll hopefully recognise pretty quickly that we can do some work there and get down to quite a simple function to start off, from the word go basically, to make our differentiation a lot easier. It doesn't really disadvantage our method students because even if we didn't recognise this identity, we can still solve that using our quotient rule, but it's where we've got the advantage of doing specialists where we can do the question a little bit quicker. So hopefully they'll get you through the work on this section.